Hello, today we are going to talk about how to generate application programming interface, so API documentation from KDE frameworks and KDE libraries. We are using the tools Doxygen and kapidox. This is how the end result looks like. This is the list of classes that are exported from the KDE frameworks version 6 named karchive. This is the class list. The main page, there's a picker for identifiers. We can see the methods of a class. The C++ include header file. For the class, we can navigate inside of the code. We can see the inheritance diagram. So the class karchive is inherited by the class k7zip, including going inside of the Qt documentation. All of this is generated from C++ source code, including the comments which surround a C++ identifier. Okay, so first of all, let's see what Doxygen is. Doxygen is the tool that extracts information from C++ source code from abstract syntax trees. It knows how to interpret the C++ source code. It also extracts information from documentation comments. We have guidelines on what type of comments you should add to your C++ identifiers, to C++ classes. There's the possibility of adding images, of adding sample code. You can document function and method arguments, parameters, the return value of a function. After your C++ source code is documented in a way that's suitable for Doxygen, next up comes to add additional files that are needed such that kapidox works correctly on your Git repository. So let's follow the kapidox documentation and see what this is all about. This is the official KDE Git repository for kapidox, invent.kde.org/framework/kapidox. It's a Python source code project, and we are going to use docs files, so files with the extension docs. The end result can be published in the central website where KDE frameworks and libraries make their API documentation HTML websites available. So there's a group for all of the KDE frameworks, 80 of them. They're grouped by the tier. So there's tier 1, which are KDE frameworks that can only depend on the Qt framework. There's tier 2 that can depend on tier 1 frameworks and the Qt framework. Tier 3 are more KDE oriented frameworks, are harder to be used by non-KDE projects. Okay. This is the group for KDE frameworks. It's grouped in here. We can also see that it says that some of these KDE libraries work on the following platforms. When you navigate to one of these libraries, let's say kconfig, it will say that it's supported on all of the operating systems that we support, so Android, Free, BSD, Linux, Windows, Mac OS, but not on iOS. On iOS, many KDE frameworks are not supported. Then there's also this note where maintainers are needed for a platform. There's also API documentation for QML libraries, so Qt Quick and QML libraries. You can see the structure of namespaces. You can see the source code line where this symbol is defined. And the rest of the KDE libraries that are not part of the KDE frameworks are shown top level in https://api.kde.org, ignoring the part the KDE framework. So there's many KDE personal information management libraries and other libraries. I'm not sure exactly what's the order in which they're shown in here. Two groups and then alphabetical. Okay. Back to the KDE Git repository for KAPI docs. It says that it requires Python 3. It will install all of the Python packages needed inside of a Python venv. If we run this command line, bash and then bootstrap -devenv.sh, we will need doxygen, which requires graphviz, which requires a tech package, techlite, techlive. Okay. We could either git clone the Git repository. Okay, so it says that we will have 3 directories in the same directory. So Kirigami KAPI docs, Kirigami docs. Let's go there. So this is, let's create a directory, temporary directory. The first 2 directories will be just git clones. The 3rd directory will be created locally for build artifacts. And then we enter the KAPI docs Git repository. So the KAPI docs is written in Python. It wraps doxygen and will create API documentation HTML websites similar to what we see in api.kd.org website. And we'll extract the source code structure and the source code comments from, in this example, the KDE Frameworks version 6 Git repository Kirigami. And the intermediate directory will be this one, Kirigami docs. Okay. So we have 3 directories. Next up, let's see the source code of KAPI docs. So it's Python, has a requirements file and a bash script file which will create a venv named .kapidocs_venv. We'll install and upgrade pip, IP, and wheel, the package manager. We'll install all of the needed pip packages from requirements frozen.txt. And then it tells us that we will need to activate that virtual environment. Okay, the Python virtual environment has been created correctly. Now we can enter it if we want. Let's see what we should do next. We're using bash, so we can use source. Otherwise, the syntax might be, the command line to run would be different. So for CSH shell, you should use activate.csh. For the fish shell, you should use activate.fish shell, the fish script. Okay, now it says that we should activate because we will run KAPI docs generate. So let's activate the Python venv. We can see that we're inside of a Python venv because we have between parentheses the directory where the venv Python virtual environment is located at the start of the bash prompt. Okay, and now we can see that this executable is on the path. So this is the venv directory, there's a bin subdirectory, and then KAPI docs generate. Okay, now it says that we should go to the third directory, the one that's empty, where we want to generate the HTML websites with API documentation. It's empty. And we say the tool KAPI docs should generate documentation using Doxygen, etc. from the directory Kirigami, which contains the Git clone of the Kirigami KDE Framework version 6. It's going to take a while. It's going to read a ton of CPP files. It's going to understand those. It's going to go through QML files. And then it tells me that it found Doxygen configuration files. And those are or an older version of Doxygen. My Doxygen version is 1.9.4. And the one that's used for building the API documentation is 1.8.17. If the version of Doxygen that's used to generate api.kd.org would be newer, then it's a good practice to run doxygen -u in order to convert the Doxygen configuration files to use the current version of Doxygen, to upgrade the Doxygen configuration files. Okay, let's see what we have in here. So there's an index.html, which is the entry point to the website. Okay, we should have a file named index.html. We saw that thing. We can open it using xdg open, which is the cross desktop environment way of starting a web browser, using the settings of the current user in the current desktop environment for file type associations and protocol associations. So this should start Firefox, hopefully, in my case, which it does. Okay, so this is the website api.kd.org. And on the right hand side and on the left hand side, we have the files that I have generated locally on my computer. Hopefully they're very similar. Okay, the links do not work. I have a merge request in order to fix this thing. Class list. This is probably for KDE Frameworks version 5, not 6. How can we prove that thing? Where does it say if it's KDE Frameworks 5 with Qt 5 or KDE Frameworks 6 using Qt 6? I don't know. Okay, so the documentation HTML website has been created correctly. We can navigate. We can use the class picker. I'm not sure if the search works, but if it doesn't work on my computer, it certainly works on the remote computer. So maybe there's some issue on my computer. And if I generate the documentation and the KDE build infrastructure generates the documentation, if search works on api.kd.org, that's enough for me. Okay, so we generated a file list. Looks very different. There's no directories. Okay, next up, we have generated correctly the index.html and the other files. You can edit QML or .h files, regenerate, rerun KAPI docs and see the differences. And like so, you improve the documentation for, in this case, Kirigami. Okay, and in order to regenerate, API docs generate will refuse to use a directory that already contains files. So Kirigami docs contains files. If you run the previous command line, which is kapi docs generate /kirigami, it will complain that it needs an empty directory. So we're in Kirigami docs. We should delete all of the content of the directory and then we can regenerate. And this was us git cloning the kapi docs git repository and the Kirigami git repository. Since I program for KDE, I already have at least one KDE SRC build installation for Qt 6 and KDE Framework 6, which already contains most of the KDE git repositories git cloned. So there's no need to git clone again the same git repositories. So we can do what the documentation here says, which is, where are you? Which is use the already git cloned KDE git repositories from KDE src-build. Okay. So we should build kapi docs and Kirigami. So that's tilde/kd /src/kdsrc-build /kdsrc-build and then kapi docs and Kirigami. So I'm running these two command lines at once. Just 3 git repositories to build because kapi docs doesn't depend on anything. Everything depends on sysadmin repo metadata and extra CMake modules. And then Kirigami is also without any dependencies. They're tier 1 KDE framework version 6. Okay. So in the tilde/kd/src, or no, it says we should create one Kirigami docs straight in my home directory. Let's do that. Let's make sure it's empty. It is. And then we should go to the git clone of kapi docs, which is this thing. And then we're creating the VM. Let's remove it. Actually, let's do a bit of cleaning up here. Okay, so the remote git repository, remote origin master branch, which is this guy, and the local master branch point to the same git repository. When I did kdsrc-build kapi docs, it actually git fetched the latest changes from the official git repository of kapi docs, so I'm up to date. Now I can clean up. Okay, so it has deleted the directories that are not part of the KDE git repository, including the .kapi docs _venv. So the git clone is really clean. Okay, next up, we need to create the venv pip install 10 packages. Then we're going to activate the venv. Source API docs venv bin activate, the same thing that's written in here. And then we go to the directory where we want to generate the HTML, which is in my home directory, Kirigami docs. Again, KAPI docs generate is on the path environment variable because when we enter the Python virtual environment, the path environment variable changes. The bin directory inside of the venv is the first in the directory in the path environment variable. Okay. And now we're generating the documentation. And as it says, we can enter a development loop where we have opened the end result. Which is this thing. We have a command line shell where we can run commands. And then we'll need to edit the source code of the Kirigami Git repository in order to improve the documentation. So let's do that. Kirigami. Let's, for instance, open it in Visual Studio Code. Okay, so placeholder message. Let's get some. Don't we have a Visual Studio Code extension for syntax highlighting of QML? Yeah, in the meantime, let's actually use Gate in here. Okay. We need to find a file that's documented. So Kirigami2 class list icon sizes in Kirigami units. So I'm searching in the KDKate text editor in the projects tool window. It shows all of the files because I have opened the entire directory of the KDGit repository Kirigami using Kate. And now I want to go to this page, which is Kirigami units. So I search for unit. Finds just one .h file, which is named units.h. We can also see the name of the file in here, units.h. We can see that it's the same files. And we want to improve the documentation for the symbol icon sizes, which is a C++ class that inherits from the Qt framework Q object. Provides access to platform-dependent icon sizing. It's missing a dot, right? sentences should end with dots. Hello there. Okay, so we're in the directory where documentation will be generated. We need to regenerate. And then we can refresh the web browser. And now it says hello there. We can see it in units underscore 8h underscore source.html, which is the Doxygen generated HTML file for this units.h C++ source code file. Then it should also be in the class icon sizes, which is this one. Detailed description. So now it has a dot and we have our test text. Line 33. Kirigami units. So this is the way you incrementally keep fixing or improving the documentation that's available in already existing C++ or QML source code from the KDE community. A simple step that you can take here is to actually proofread the entirety of the generated HTML documentation. So we could go something like copy this content or entire content like this. Yes, Control C, and proofread it, for instance, by using a Google Docs document and then running the spell checker from there. Or use other spell checkers. You can use LibreOffice or maybe, I know, Microsoft Word or Grammarly or anything else that comes to your mind. For example, I have an empty Google Doc that I use for spell checking. When I copy, I'm careful not to copy C++ source code because that will have many spell checking issues in Google Docs. I want to use the generated documentation. So it might be a PDF file. The entire API documentation for a library can be generated as in PDF format. Once you open that PDF in a PDF reader, you can go Ctrl-A, Ctrl-C to copy the entire contents. And this way you will see most of the proofreading issues for the entire library at once. If not, if you're using HTML, you will need to navigate through the classes, so this will be more tedious. But let's see how we can do it just for this HTML content. So again, we're not looking at the C++ source code, at the QML source code, or at the HTML source code. We're using just what's meant for the user to read, which is this text. Ctrl-A, Ctrl-C. How do we paste without formatting? Ctrl-Shift-V. Ctrl-Shift-V. And then pools, spelling and grammar check. There will be a ton of identifiers which we'll need to skip. The QML tool is actually an executable, so it's valid what says in there. The C++ and QML samples will be a problem. User names will be a problem. So all of these text seems okay for the Google Docs tools, spelling and grammar check tool. Let's actually try to get a PDF and paste it in here, see what happens. Okay, so kapidox uses Doxygen, but it instructs Doxygen not to generate LaTeX by default and not to generate PDF by default. It only generates HTML output in order to be as fast as possible. So I went into the kapidox Git repository. I searched for PDF. Did not find anything. I searched for LaTeX. And I found that generate LaTeX was no. So I changed it to yes. And then I also added this to configurations to the Doxygen configuration file in order to have a better looking PDF generated. Then I have run again the command to generate kapidox. And now we have this is how the tilde/kirigami docs directory looks like. In here, files generated by Doxygen will be created. There's a subdirectory named kirigami. And then there's HTML output, which we had before, and new. Now we also have a LaTeX directory, this guy. And in there, we need to generate the PDF, which is done using the GNU make command. So this took a while, and then the generated PDF file is called refman.pdf, so reference manual.pdf, which I'm going to open with the default configured application for PDF extension, which in this case is Ocular. Hopefully the PDF viewer works correctly because these files tend to be quite large. It's a almost 3 megabyte in size file. Doesn't really contain images, that's why it's so small. It only doesn't contain the dot generated GraphViz graphics with class inheritance hierarchy. Okay, so let's go Control A. It's going to take a while. Right click, copy text, and paste it in the Google Doc. Control A, delete, Control Shift V. Let's see if it works. It does, because the web browser is blocked right now. I'll be back once it finishes pasting. So this PDF content is very heavy for both Google Docs and LibreOffice. You should probably just paste 1/10 of the content of the PDF file into these. Otherwise, you'll have all sorts of issues, long wait times, huge swap usage, etc. The PDF can be opened correctly in Mozilla Firefox. I tried to copy paste, something worked, I'm not sure exactly what. It says that there's 1150 pages in this Google Doc. Let's see if spelling and grammar works on such a thing. No, it does not. So yeah, let me try with just a subset of the PDF file. What should we open? Let's select all pages from 30 to 39. There's a ton of identifiers and code samples. Shift click doesn't work. So I managed to select 10 PDF pages. I went to the page 30, selected a bit from the page, which will be the start point of the selection. And then I'm going to the end of the selection, page 39. And I go shift click, but only when the cursor is not arrow, but the text editor cursor. So in this case, shift click. Right click, copy, and then Control Shift V. Okay, so now we have only 9 pages out of the 1100. There's a quite long way to go. Tools, spelling and grammar check, Control Alt X. Address bar. Now this is a common one where we as programmers think of a checkbox as a single word, or the status bar a single word, whereas some dictionaries do not allow such single words composed out of 2 words. So I'm not sure if address bar is wrong here. Same for title bar. Address bar, title bar. And when is it wrapping? It already did wrap. Okay, so that was successful. Now I'm trying pages 40 to 69. It's pretty hard to scroll through the PDF, so I'm using the sidebar, show document outline, and I'm copying from subsets of the hierarchy of the document outline. So I'm starting from chapter 9 until chapter 9.9. Select a bit here, chapter 9.9, 9.10, this, and shift click here. The correct selection was made, right click, copy, Control A, Control Shift V. Okay, that was a small selection. We'll need to make a bigger one next time. Abstract card is probably the identifier name of a class. And that's it. Let's start from chapter 9 and go be very bold. Nine dot 30. Just 4 pages. From 9.9 it jumps to 9.28. So there's something fishy going on. Okay, but that's the big idea. You use a tool that knows how to do proofreading, might be LibreOffice, Microsoft Word, Google Docs might be one of the JetBrains integrated development environments such as C-Line or PyCharm, or a web-based tool, and just paste in there parts of the kapidox generated PDF file. I'm sure there's proofreading issues in all of the kapidox generated PDFs for all of the KDE frameworks and libraries. There's bound to be, because there's millions of words there. Okay, so as a recap, the way I told kapidox to, besides generating HTML websites, to also generate PDF files are these three changes that I did to the kapidox Git repository. So replace generate LaTeX no with generate LaTeX yes, and then I added use PDF LaTeX and PDF hyperlinks, both with a value of yes. Then you navigate to the directory where the LaTeX files are generated, which is in this case /kirigami docs/kirigami/latex, and in there you go make, and it takes a while. This will contain all of the text that's found in the kapidox HTML website and none of the images, which is okay. It will still generate a huge PDF file. Okay, and then in the PDF file you can open it with any tool you like, such as Firefox. It's called refman.pdf. Okay, starts with a start page and then has the table of contents. You can click inside the table of contents. There's HTML hyperlinks inside of the PDF. Inside of the documentation for C++ source code, you can navigate, such as like this. You cannot navigate inside of the QML files. So QML files are not that well understood by Doxygen yet. Okay, so inside color utils you can navigate to, for instance, brightness, whereas inside about item you cannot .qml, you cannot navigate anywhere. There's no hyperlinks in. Okay, and finally, the KDE community has some web pages, more documentation about how to document API. Okay, so in the KDE Git repository frameworks KAPI docs, we read how to run KAPI docs. Next up is how to actually write documentation, how to improve the documentation that we have in the C++ and QML source code. There's this wiki page, which says that in addition to comments and source code, you will also need in the repository root, so in this case Kirigami. Where is Kirigami? We need to have a file that's named readme.md or metainfo.yml. There's such a metainfo.yml, which generates this part where many KDE Git repositories API documentation are going to be grouped under api.kd.org under KD frameworks in here. And that's done by using some special configuration just for KD frameworks. And similar configuration is also used for the KD personal information management libraries, such as specifying the tier. And then tiers are used here with the list of libraries and also in the table of contents. Okay. Then also for all of the KD frameworks, you have the platforms that are supported and if they require a maintainer. So in the case of Kirigami, it's this list. There's also the description, which is this, and the maintainer, which is this person. Type functional, not deprecated, and this logo.png is this thing. And we can see it being used when we open the index.html. Which is this thing. It's visible at least in here, the icon. Okay. Then additional Doxygen chunks, so parts that will be presented in the final output generated by Doxygen but are not actually source code, can be added in the form of files with extension docs. And this is needed in the main page. So in here. For instance, this list of main components is actually written by a human in here. Subsection, components, main window components, and then a list of hyperlinks. And these things get converted to this HTML. So this is how Doxygen generates HTML out of this Doxygen input. Doxygen generates HTML, LaTeX, PDF, and man pages. So this Doxygen source code is suitable to be transformed in all of those four destination output formats. Okay. There's additional Doxygen documentation. Most of the things that are inside of the Doxygen documentation are valid also for KAPI docs. Okay. Then there's a special C++ preprocessor macro which is called kdoxygen. The old name of this thing was Doxygen should skip this, which we're using in order to know when Doxygen is reading the source code, not the C++ compiler. Okay, so we need additionally for besides Doxygen, KAPI docs specific input files, readme.md, main page.docs. There's no such thing in here. and metainfo.yaml. From the readme.md file, a very important line is the first one, which is the title of the documentation. So this one, Kirigami 2. Okay, so that's about it of the documentation. You need to know Doxygen and then the extra specific things for KAPI docs, the extra files. You can have additional subdirectories. You can have either use the default Doxygen configuration that's specified by KAPI docs. If you want additional Doxygen configuration items to be different from the defaults, you can use a directory docs/doxyfile.local. Let's see if such a thing exists here. No, it does not exist. We just edited this file from the KD Git repository KAPI docs. Okay. There's also docs pics with images, screenshots, etc. Snippets inside of the examples top level directory. Additional dot files, which it means additional graph viz graphics in docs/dot directory. Additional values that can be stored inside the metainfo.yaml file is available here, but then this syntax at ref metainfo underscore syntax is not a valid markdown, not valid GitLab markdown. So it's actually valid Doxygen. So this file, the readme.md from KAPI docs, is actually used in order to generate a KAPI docs Doxygen HTML website. And in there, the link will work correctly. So let's go there. Where is it? api.kd.org, KD frameworks. And in here, we're looking for KAPI docs. This thing. And in here, there's whatever is written in the readme.md file. And that additional part is here where it says a comprehensive list of available keys can be found on this page. Comprehensive list of available keys can be found on this page. So this is invalid markdown because it has a space in URL, whereas it's valid Doxygen. And the URL is correct, so api.kd.org/framework/kapidocs/html/metainfo_syntax.html, which is this, the list of all possible keys then can be put inside of the metainfo.yaml file. Okay. Additionally, I searched all of the KD wikis for KAPI docs, I found these wiki pages. community.kd.org/guidelines and how-to/API_documentation. techbase.kd.org/developer/tool/API docs. This might be for a previous version, not for KDE API docs and Qt 5 KDE frameworks version 5, but for Qt 4 and KDE 4. And then the page that we saw previously, community.kd.org/frameworks/frameworks_documentation_policy. This is the entry points besides this one for understanding API docs, KAPI docs. So if you want to start from somewhere, first learn all there is to know about Doxygen, especially related to C++ and Qt. I have a screen recording for that. And then on top of it, add information about KAPI docs. You can start, for instance, from here, api.kd.org/framework/KAPI docs/html/index.html. And then the frameworks documentation policy KDE wiki page. So this is it. You could help improve the API documentation for KDE Git repositories. You can proofread, you can add more documentation, you can improve documentation that's not up to date. Maybe a identifier such as a method name has been changed, but then the documentation strings above it have not been. Maybe somebody did a refactoring, rename method refactor, and did not change the documentation strings. So these are ways to do KDE GitLab merge requests, which do not take that much time to actually find an issue and correct it. And they will also be really easily merged and accepted. Thank you.